Have you ever wondered what lies at the heart of the universe? What is the fundamental fabric of reality? The answer may lie in a theory that has captured the imagination of physicists and cosmologists for decades: string theory. String theory is a theoretical framework that attempts to reconcile the laws of quantum mechanics and general relativity. It proposes that the fundamental constituents of the universe are not particles, but one-dimensional objects called strings. Strings vibrate at different frequencies, giving rise to different particles and forces in the universe. This means that everything in the universe, from the tiniest subatomic particles to the largest structures, can be described in terms of vibrating strings. But string theory goes beyond just describing the universe in terms of strings. It also proposes that there are extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These extra dimensions are curled up and hidden from our everyday perception, but they play a crucial role in string theory. In fact, string theory predicts that there are 10 dimensions in total. To make sense of these extra dimensions, physicists use mathematical objects called Calabi-Yau manifolds. These manifolds are like shapes that the extra dimensions can be curled up into. String theory has profound implications for our understanding of the universe. It suggests that all the forces of nature, including gravity, can be unified into a single theory, known as a theory of everything. This theory of everything would be the holy grail of physics, allowing us to understand the universe on the most fundamental level. String theory is still a work in progress, and there's much we don't know. But the beauty of string theory is that it provides a framework for bringing together ideas from different areas of physics and unifying them into a single theory. String theory is a fascinating and complex topic, but it has the potential to revolutionize our understanding of the universe. If you're interested in learning more, be sure to check out some of the great resources on this subject. One of the biggest challenges in modern physics is to reconcile the laws of quantum mechanics, which govern the behavior of particles at the subatomic level, with the laws of general relativity, which describe the behavior of large-scale structures like planets and galaxies. These two theories appear to be incompatible with each other, and this has led physicists to search for a theory that can unify them. String theory proposes that the fundamental building blocks of the universe are not point-like particles, but tiny one-dimensional objects called strings. These strings are incredibly small, on the order of 10 to the power of -33 centimeters, and they vibrate at different frequencies to give rise to different particles and forces in the universe. For example, the electron can be thought of as a string vibrating at a particular frequency, while the photon can be thought of as a string vibrating at a different frequency. One of the key ideas in string theory is that the universe has more than the familiar 4 dimensions of space and time. In addition to the 3 dimensions of space and 1 dimension of time that we experience in our everyday lives, there are 6 or 7 additional dimensions that are curled up and hidden from our perception. These extra dimensions are necessary for string theory to be consistent, and they play a crucial role in determining the properties of the particles and forces in the universe. To make sense of these extra dimensions, physicists use mathematical objects called Calabi-Yau manifolds. These manifolds are like shapes that the extra dimensions can be curled up into, and the particular shape of the Calabi-Yau manifold can affect the properties of the particles and forces that we observe in the universe. One of the most exciting implications of string theory is the possibility of unifying all the forces of nature into a single theory, known as a theory of everything. This would include the strong and weak nuclear forces, electromagnetism, and gravity. In fact, string theory predicts that gravity should be described by a particle called the graviton, which has yet to be discovered. However, string theory is still a work in progress, and there are many open questions and challenges that need to be addressed. For example, there are many different versions of string theory, and it is not yet clear which one, if any, is correct. Additionally, string theory makes some predictions that are difficult to test experimentally, so it is currently not possible to directly confirm or refute the theory. Despite these challenges, string theory remains one of the most promising avenues for unifying the laws of physics and understanding the fundamental nature of the universe. It is a fascinating and complex topic that continues to captivate the imagination of scientists and the public alike. Thanks for watching, and don't forget to subscribe for more videos on science and technology.